So if I have an x squared function, a square root of x, just an x, cubed root of x, or 1 over x. These are some cases that I could see that ask me for domain. So anytime I have x squared, it could be x squared or x squared plus x plus 5, or just x squared plus 5, something like this. Anytime I have an x squared term, my domain is all real numbers. Don't even have to think twice about it. Your domain's all real numbers. There's nothing that we can't plug into this x here. We have no restrictions. Domain is all real numbers. Now when we have the square root of x, this is where things get a little bit tricky. So what can we not have under a square root? We cannot have negative numbers. Can't have negatives. So anytime we have a square root, we need to set what's under our square root greater than or equal to 0, because it has to be something bigger than or equal to 0. So here we would just have x is greater than or equal to 0, so we would write that in our interval notation as 0 to infinity, because x can be anything from 0 to infinity. Now to make it a little bit more complicated, we could say if we have x plus 2 under our square root. Again, we do the same thing. We set what's under our square root greater than or equal to 0, because you can't have negative numbers under the square root. And we would want to solve for x. So how can we get this x all by itself? What do we have to do to solve for x? Just under the square root. So it's only x plus 2 is greater than or equal to 0. Subtract 2. So we have x is greater than or equal to negative 2. So x can be from any number, negative 2 to infinity. It can be any number bigger than negative 2. So in interval notation, we would write it from negative 2 to infinity. So we only set what's under our square root greater than or equal to 0. And that'll give us the domain, because we can't have negative numbers under the square root. Now this works for the fourth root. We had the fourth root of something. If we had the exponent of 1/2 or the exponent of 1/4, anytime our index is even, we have to know that we cannot have negative numbers here. So anytime we have an even index. All right, what about for x? If we just have an x term, nothing happening to it, just an x. What do you think our domain is? All real numbers. And this would work for x plus 5, x minus 100. We can have all real numbers here. Anytime we have an x, we don't have a square root happening to it. We have all real numbers. What about the cubed root? Can we have negatives under a cubed root? Yep. So we have no restrictions on our domain for cubed root either. We have all real numbers here. And then our last case is when we have a fraction. What's the one thing we can't have in a fraction? 0 in the denominator. So x cannot be equal to 0. So to find what your domain is when you have a fraction, you just set your denominator not equal to 0. Because we can't have a fraction be anything over 0. This is undefined. Undefined. Can't have 0 in the denominator. So here, we would write our domain as all real numbers except 0. Or we could also see it in interval notation as negative infinity to 0 and then from 0 to infinity. So just remember that the parentheses means that it's not included. So we're including all values really, really close to 0, but just not 0. So this is not included. So if we had something a little bit more complicated, let's say 1 over x plus 6, we just set our denominator not equal to 0 and solve for x. So how would we solve this for x? Subtract 6. So x cannot equal negative 6. So we would write this as all real numbers except negative 6. Or we could write it as an interval from negative infinity to negative 6 and to negative 6 to infinity. So the only time we have to worry about our domain is whenever we have a square root with an even index or if we have a fraction. So these are the only two cases you have to worry about your domain. All the other times it's going to be all real numbers, or all real numbers.